Hey guys, welcome back to the channel. In this video, we'll be talking about a very common topic talked about in integral calculus, volume by revolution by cylindrical shell method. So let's just hop right into it. This problem was submitted by a viewer. If you would like to do that, either message me on Instagram, yt_the Swiss Army Tutor, which will be in the description, and also the email, the Swiss Army Tutor at gmail.com. In the description down below. But make sure you have all the specifications for a problem, and we'll get to it. So let's just hop right into it. So the problem today is find the region generated by revolution using a cylindrical shell method. And we're given the function x is equal to 24y squared minus 8y cubed, and x is equal to 0 about the y-axis. And the first thing you always want to do is sketch the functions out. Sorry, my drawings aren't that good when it comes to this by hand. If I actually had the software, I would show you guys on computer what it looked like, but pretty much you take your function. So this 24y cubed or squared minus 8y cubed, and what you're going to do is you're going to draw it. It looks like a cubic function. It's a cubic function on the x-axis because we switch x with y in this case, and then we have x is equal to 0. So it's a horizontal line at the origin, going straight to the origin. And so pretty much then we're going to reflect across the y-axis since we are revolving around the y-axis. So we draw it at the points here, and on the y-axis we reflect it, and then we draw a circle closing it off. It looks like a vase, kind of, and taking a shell, a cylinder, okay. Our volume element is, you always want to draw your volume elements to see if it's going to be vertical or horizontal. If it's vertical, it respects to x. If it's horizontal, it's with respects to y. And so pretty much our volume element has a radius of y. So it has a radius of y. And so with that, pretty much what we do here now is we need to find our limits of integration. Oh, I also mark the graph with a delta y or a dy, so I know it's with respects to y. And so now when you find the limits of integration, since we're in terms of y, it's going to be on the y values. Okay, so it'll be these vertical values will be the limits instead of the horizontal values. And so to do so, you set the given functions equal to each other. So 24y squared is equal, minus 8y cubed is equal to 0. Factor out an 8y squared, you get 8y squared times 3 minus y is equal to 0. And setting each factor equal 0, you find y is equal to 0 and y is equal to 3. So this will be our lower bound, a, and this will be our b. Now we set up our integral. The formula for volume by revolution is v is equal to the integral of a to b of 2 pi times x times f of x dx. All right. But in our case, because we're in y, we switch it with y. So we change in terms of y, and v is equal to the integral of a to b times 2 pi times y times f of y dy. So the function. Okay. So we could say now the volume is equal to the integral from 0 to 3 times 2 pi times y times 24y squared minus 8y cubed minus 0. So this f of y is actually everything subtracted from each other. The functions subtracted from each other as well. And so pretty much is that okay. Well, we plug it all in since it's 0 here, so since it would be minus 0, well, it'll just be this piece here. All right, so since 2 pi is a constant, we could pull it out. We could pull this out front. We have v is equal to 2 pi times the integral of 0 to 3 of 24y cubed. Oops, I messed up there. Of 24y squared. Oh, no, I didn't. Sorry. We distribute the y. Clean it up. And we get 24y cubed minus 8y to the 4th dy. So pretty much what we did was we pulled out the 2 pi and we distribute the y. and then we evaluate this integral. So we have 2 pi on the outside times 24. So the integral. So if we find the antiderivative of 24y cubed, it'll be 24y to the 4th over 4, using the power rule, minus 8y to the 4th here would be 8y to the 5th over 5. You evaluate it from 0 to 3, 2 pi. And so this reduces that down to 6. Okay. So we subtract. So then we plug in our functional values. And we know since, so from 0 to 3, so we evaluate the function from 0 to 3, so it'll be 2 pi times, so 24, and 24 and 4 reduced down to 6. So we have 2 pi times 6 times 3 to the 4th, minus 8 over 5 times 3 to the 5th. And since we have a 0 and there's no constant terms, it'll just be 0. 2 pi times 6 times 81, minus 1944 over 5. Finding the common denominator, we find 2 pi. We find 2 pi times 2,430 minus 1994 over 5 is 872 pi over 5. That's how we find the volume by revolution through cylindrical shell method. So pretty much what we do is we always sketch out the region and the volume elements. Then we find our limits of integration if they're not given to us. Then we plug in all the given information into our formula, integrate, and evaluate, and you're done. You guys have a great rest of your guys' day, guys. And just remember, if you guys enjoyed the content, leave a like, comment, subscribe to the channel, and also it's a great day to change lives, guys. Later.